Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.FM radio. It is another Friday evening. This one happens to be October the 27th, 2017, 9 o'clock-ish in the evening for those of us here in the eastern portion of North America, also known as 1 o'clock in the morning, October the 28th, Saturday morning, 2017. My name is Marty Kunz with my co-host.
Good evening, it's me, Nick Evetts, 2 Echo Zero, Lima Uniform November, and oh my god, it's early!
Halloween season coming up next Tuesday. The Day
Samhain,
of the Dead.
yes, Samhain, yeah.
Yep, Day of the Dead. What else is there?
Well, actually, it's the beginning of the Celtic New Year.
Oh, that's
if you
even
want to
better.
get really scientific, it's the beginning of the Celtic New Year.
Okay.
So, the Celts, they had 2 seasons.
Do you know what year it is?
Summer.
Do you know what Celtic year it is then?
They
Do they have their
didn't
own?
really keep a calendar as such. I think it was, if anything, it was a lunar calendar like the Chinese one.
Mm-hmm.
But having said that, they kept 2 seasons, winter and summer.
Yeah.
And the other thing about Samhain or Halloween was it was the time that the veils between the worlds were thin, and members of the family would come back to see just how well the living are doing, or hope they're doing.
Mm-hmm.
That is the boring prosaic facts about Halloween. Nothing to do with trick or treats or scaring the bejesus out of the neighbours.
That's
and I hear clown costumes are banned this year in some places.
Yeah. Somebody wanted clown costumes. Who was it?
Well, I hear that some universities have actually banned them.
Oh, I know it. I think I saw this. I think it was like Burger King that wanted people to come in with their clown costumes on because they have a. Is it Burger? Oh, or is it McDonald's? I don't know.
McDonald's. It'll be McDonald's.
McDonald's. Yeah, they want people coming because they have their own clown.
Yeah, Ronald McDonald himself.
Mm-hmm.
But anyway,
enough for that.
Yeah,
they're not our sponsor, so. Yeah.
No, they're not, unfortunately. If they were, they would just get mentioned like they just did, and that would be it. But they're not our sponsors.
That's right.
Moving on to more interesting things. The sky is really giving our professional brethren quite a turn.
There's all kinds of stuff going on tonight.
Absolutely.
And, well, this week and that.
And everybody's probably heard about well, originally it was C2017 U1. It was a new comet. Now it's not a comet anymore. It's now designated a letter A, which normally tends to be an asteroid, as I remember my Minor Planet Center stuff.
I do think that's correct.
So now it is a asteroid. And Alan Fitzsimmons has actually managed to obtain a spectra Wednesday night. So as you lot were busy doing pirating stuff, Alan Fitzsimmons, who is astronomer, Banafy pie maker, and a few other things, was outside imaging Alpha /2017 U1, and he got a spectra. So I actually have a link to all this. So, but unfortunately, because the chat room is messing up on us, you're going to have to go to the show notes, I'm afraid, folks. But the links will be there, I promise you. In fact, I'm being PM'd already on Facebook about it.
There's an article on NASA homepage too, so you can check that out. It's titled "Small Asteroid or Comet Visits from Beyond the Solar System." They've got a nice orbital diagram. Other thing passing by too. It's definitely a hyperbolic orbit, which means it's one of the shapes of a cone. So if you slice a cone, depending on how you slice it, you either get a circle, you get an ellipse, you get a parabola, or you get a hyperbola. And ellipse is circle is a circular orbit, and ellipse is a oval-shaped orbit. A parabola is when it comes in from one direction and then goes around the foci and then goes back pretty much towards where it came from. And a hyperbola is when it makes a really wide angle, so it comes in from one angle and goes off in a completely other direction. Just looking at this diagram, it almost looks like it's going off at about a 90-degree angle. I'm sure it's just the perspective that I'm looking at, but no way is it going back to where it came from.
No, the interesting thing is a lot of people are bringing up the old Arthur C. Clarke story, Rendezvous with Rama, because of it. Because in the story, there is a huge man-made object on a hyperbola, and they were racing to explore it, and it was an interesting story. If you like good old-fashioned rip-roaring science fiction, go and do it. And apparently, according to Colin Snodgrass, time with the ESO VLT approved. Hopefully, they'll get some spectroscopy very soon, weather and other telescope units permitting. So this has really, really caught people's attention. Now, Alan Fitzsimmons' spectrum was done with the La Palma 4.2 meter WHT. And he's saying that the color is red, and it's kind of like a Kuiper belt object, but it's featureless. So it is definitely very, very fascinating, or might say curious.
It's not real big, too. It's only about quarter of a mile in diameter.
About that, yeah. But the interesting thing is we're more in a situation where we can actually investigate these things. It is it's a very dim, it's about magnitude 20. I should know, I have been trying to image it when it was still called a comet. Now it's an asteroid.
Nothing there. Probably not outgassing then.
Well, supposedly it was, but
really?
The problem is there are a lot of comets out there that act like asteroids, and a lot of asteroids that act like comets. Now, whether or not this is just purely, and that's because the asteroid is beginning to disintegrate and therefore producing a coma, is open for discussion. I know that a lot of people, particularly in the professional world, are very, very keen to get to the bottom of this. And maybe this is one of the things that OSIRIS-REx will help answer. However, having said that, we do need more and more missions to these objects. Obviously, some things like this are like very short notice. So perhaps we need a reservoir of space probes sitting in orbit, waiting for a destination. And when you think about it, if you're using mass production, maybe this is a way to get maybe 5 or 6 probes into orbit waiting just for such a mission. They can have a fuel tank and engine pack fitted, perhaps strapped on by astronauts and cosmonauts from the ISS, and then sent on a very fast trip to wherever they need to go. Obviously, the biggest issue with a lot of this is how much fuel can the probe carry with it.
Right.
Now, the other thing, of course, is the new ion drive has proved spectacularly good, but it's a thing that has to build up. We know from experience that you can't just turn an ion drive and then drive it like a car, like a race car at high speed and just hit the floor. It takes time to build up the speeds. So maybe having a combination of chemical and ion drive, using a chemical engine initially to give it a real good kick in the right direction, and then switch into ion drive when the velocity is built up through perhaps single or multiple burns from a chemical rocket. Maybe that's the future for such missions to interesting objects like a 2017 U1. Now, hang on 1 second. I'm getting PM'd on Facebook.
All right. I'm looking at the orbital diagram here. It looks like it came in from north of the plane of the solar system within the orbit of Mercury, and it went south of the plane of the solar system, and then next time it crossed the plane of the solar system, it was between the orbit of Earth and Mars, somewhat close to the Earth. A very open curve to its orbit. Now, which makes me think like, ooh, there's a possibility. It's really rare, but it is a possibility of something like this could come in and hit us.
Perhaps it's something that's been perturbed out in the outer Kuiper belt. We know that our solar system extends almost halfway to out to the Alpha Centauri system.
Yep.
So perhaps something has happened out that way that has given a slight nudge to something in the outer Kuiper belt and decided to send something in. Obviously, it's just looking at some of the imagings that are being done. It's moving through Pisces at the moment, very, very fast. So something's has given it quite a kick. So
well, it either gave it a kick, or again, like you said, it came from way beyond our solar system. So that's what had the initial, boost to it. Just be traveling intergalactic and getting semi close to a star, could whip it around a little faster. And
gravity assist
quite a few times. Yeah. And that also means missing a lot of objects too. But it's actually pretty easy to just blindly travel through the galaxy and not actually hit anything. That's how far apart the stars are.
But as I say, until we can really investigate these things, we are going to be kind of speculation will be rife. Very un-Vulcan and very illogical, I know, but hey, unfortunately at the moment that's what we got to do. Maybe once Orion gets up and running properly, maybe the next time this happens, we could detail an Orion mission to go out and visit and maybe get close enough, if only to have to put a telescope on it or a camera on it.
Something I think would be interesting. How about parking something in orbit, fueled and ready to go?
Well, yeah.
Get it up there, maybe a couple missions, put it up, one to put a little extra fuel in it, and basically leave it in some sort of ready-to-go orbit, either maybe around the Earth or
branch points. Ready to do a flyby for gravity system, very much like Juno did. Even with Juno's fantastic engine and the New Horizons engine, its gravity assists are really still very, very convenient. And you can actually, by setting the course specifically, it does give you a chance to send the probe where you want to go.
Yes.
So again, it is something worth thinking about. Maybe the people at ESA, Roscoff, JAXA, NASA can all sit down at a table and say, well, yeah, we need to look at these things and design a mission from common units that can just sit there and the detection of another one be excuse me, it's been a long week, be detailed to actually go and do the information gathering. Obviously, we missed out on this one. We're doing our best from Earth, and if the VLT's involved and at La Palma, they're using the very best possible instruments they've got available at the short notice. These instruments are booked up like nobody's business. They're booked years in advance. However, as Hubble demonstrated with Shoemaker Levy 9 and the Weasley event, things can be changed at the stroke of a keyboard, at the touch of a keyboard. Hubble was supposed to have only been on test objects, safe objects that they already had good parameters for the information, so they could see how the Hubble was performing. But you know what? They said to heck with that. They tore up the test manual and went straight live doing detailed imaging. Probably the best testing they've ever done at short notice. But it shows you what can be done. There was the will there. The people who run these instruments had the desire to say, hey, forget it, let's do it, let's get it done, because it was the events themselves were unique. Obviously, we discussed Shoemaker Levy 9 in much greater detail on Comet Watch, but doing this science when you have the opportunity, and even if it means kicking somebody else's observation requests to the back for a while, it happens. And I'm pretty sure most of the professional astronomy world are like, yeah, okay, fine, didn't see that one coming, and I can understand that they need the instrument then. They took Galileo and used the Galileo probe and moved it into a more auspicious position to observe Shoemaker Levy 9. Mm-hmm. Now, that took a lot of political will because it only had a finite reserve of fuel. They did it, and to be honest, they probably didn't. Someone said there, said, "Well, you know what? I don't regret this one little bit. The science we did there was fantastic. It gave us an insight of perhaps some of the more cataclysmic events in the young Earth's history. So we learned something, and it perhaps gave projects like Space Watch the more financial and political support." All I can say was these are eye-opener events, and at least obviously the people who were doing the science were only too happy to collaborate. It was a worldwide collaboration. People were in Israel doing observations as best they could. People were contributing from all over the world. Pictures were coming off and they were clearing the front pages of papers for these images. This is science like it's never been done before, and it was a wake-up call for this planet. So maybe they'll say, yeah, okay, this is going to be a wake-up call. We never saw this one coming. We may never see something like it again, but we need to be ready. I hope so. I really do, because we may have a chance to perhaps sample something from beyond our solar system up reasonably close. It takes a long time for the signals from Voyager et al. To get back to us. Even if we had some of the postulated space missions that certain entrepreneurs would love to run using nano satellites and probes from a mothership, it's not going to happen in our lifetime, I don't think. But we have a chance. We know these things can now start happening. Let's be prepared. Let's say we are going to have an international collaboration on the scale that would take man to Mars. We're going to do this. We're going to be ready for the next one. So when it happens, we can send out a probe. We can get close. We can look. We can analyze. We can report back. And to be honest, we've proven we can do this. Rosetta showed us it was possible. Rosetta set the gold standard. And this was a space probe that had its target changed because of a delay in launch. What more could you say? That was probably one of the most successful Comet missions ever done. Yeah, we were all enthralled with the original Giotto and the Vega missions to Halley's Comet. But you know what? That started the whole thing running. We proved we could go to a comet that was active. We proved we could do science. We proved that our equipment could survive the environment. Mm-hmm. And you know what? At the end of the day, it meant we could do science like Rosetta. It means we can do science by going to places like 29P Schwackman 1. Why not? This would be a good chance to put the lessons learned at I can't remember the comet's name. It's CG. I can never say the name. Menko.
Yeah.
We learned so many lessons there. We proved our technology, and if anything, we learned what we are capable of. Let's do it again. Let's look for another object like A2017 U1. Let's go there. Let's put everything we've learned putting OSIRIS-REx out into the void back into practice. We proved it with Rosetta. This is technology. Rosetta was 10 years old technology. It was behind the times. We could have equipment now that is far more sophisticated and far more advanced than what Rosetta was. Let's build it. Let's do it. Let's go to a comet that's inside the solar system permanently, that just shuttles back between Jupiter and Saturn.
Mm-hmm.
Let's go to a few places and do a few things, because now we know the possibilities are we may get visitors from another solar system. Something may be perturbed and come through the Kuiper belt and visit us. We have a chance, perhaps, to see something that is incredibly new, that's unique. And at the end of the day, wouldn't it be utterly and totally wonderful to say, we went to this object, we proved or disproved if it came from another solar system, and we have all this information. If anything, it will give us a wealth of data about not only the early solar system, but perhaps the primordial solar system. We have theories. Let's find out the facts. Let's look at the remnants of that theory, of what was left by our solar system when it came into being. When that infant Sol, that infant star of ours, decided to start really hammering everything into place. We know quite likely that the gas giants formed in the inner solar system, and they migrated out, and the inner and the rocky planets that we know today as the inner planets possibly came into the inner solar system. Let's find out for sure. Let's have something we can measure it against. Let's have some fun. Let's enjoy and do some science. I don't care what the killjoys are saying. You know what? This species was designed, it has the desire, it was given the ability to do things that are totally and utterly unique. We have a curiosity. We have a desire to learn and to understand. And by going to these objects, we get the chance. Yes, we are getting to the point we can see back into Planck time, almost to the beginnings of creation, to the universe. Well, that's great, but we also need to understand things on a closer perspective. How did the solar system formed? What does stuff from another solar system look like? Is it similar? Are we looking at perhaps a mirror of our own solar system? We know that other stars have planets. We're finding them so much now that finding out if this piece of material is a wanderer or if it was just something that was kicked out by our own solar systems, icy outer reaches. I want us to do this. And I think our kids, our grandkids, and our great-grandkids would probably have the greatest time and enjoyment finding out about what is going on in the outer reaches of the solar system. I hope they get the equipment to go to Jupiter, to Saturn, to Uranus, to Neptune, to actually finally visit Pluto and stand on the surface of Pluto, and not just put an American flag, a Russian flag, a Chinese or a Japanese or a European flag, but to put something there that says the whole of mankind came. We didn't just come as individual nations. We came as a group. We came to learn, and we learned.
I think it needs to be a space pirate flag. That's another show.
You'd love that, wouldn't you, Marty?
I would.
Space pirate flag there.
There you go.
You know,
I'm kind of retracting my statement about a orbital ready space probe, because it would probably be in the wrong orbit. So never mind, that won't work. Yeah, most likely.
Park it out at the Lagrange point. Park it out by the moon.
That still might be wrong, but
it might be wrong. But you know what? If you've got extra fuel to get it there, as well as the ion engine
and lots of math, hey, we did the greatest accomplishment was the Grand Tour of the Solar System by Voyager. Mm-hmm.
2. That was done. That was pretty much worked out on a blackboard at NASA. Some guy came into work one day, the light bulb went off. He was Eureka. He figured out how to send a space probe to nearly every planet of the solar system in one trip. Now, if you can do that...
Well, technically, now it was every planet in the solar system.
Well, yeah, but at that point, the only one they couldn't get to was Pluto.
Yep.
Because its place, its orbit was wrong.
Which I'm saying, now it's not a planet, so they did hit every planet.
You know what? I think the biggest problem is we have no complete, decent definition of a planet. The IAU changes its mind... I think it's so many times.
I think it's the solar system that doesn't have a complete definition of a planet. That's the problem.
I think the solar system decided to have a joke on us. So they let us find 9 planets. Oh, look. There's another 10, 11, 12, 13, 14. Bloody Solar system's having a joke on us. But you know what?
Should have been something even like 10 planets. You know, we're used to 10.
Yeah. Well, we don't have 10. We've only ever had the 9 officially, and then Pluto got demoted, so we're back to 8.
Yep.
Unless you decide to make things like Hyuma, Maki, etc., all planets.
And Ceres.
Ceres, yeah, okay. But the thing is, can Sol just have 8 planets, or can it be a rambunctious elder with maybe 20 or 30 planets?
How about if we just misname it like everybody else does, and we'll call the sun a planet?
Yeah, unfortunately, you have to have something. Even Jupiter's got to have something solid, perhaps at the core. Maybe that's about it, but we'll never get down there because the gravity would just crush us.
Wait, in the middle of the sun or the Earth?
I'm talking about about Jupiter.
Jupiter, okay, yep.
Now the thing is, what is the core of Jupiter? Is it metallic hydrogen? Is it a huge diamond, as they thought it could be in 2010, 2001? Or are we going to find that it's just a big cold ball of metallic hydrogen? That's the possibility. I would love to find out. I don't think I'm going to yet, but that means technically it's a planet. It has a core. We think that Saturn may have a core. Again, something small and dense.
They pretty much have some, even if it's like the size of a baseball. There's got to be some rocks in there. I mean, whatever dust was in Shoemaker-Levy 9 would have gone down to the center if it didn't burn up. But there should have been enough material just to make some sort of core of non-gaseous material.
Yeah. So, certainly in Jupiter's case, I think it would be metallic hydrogen. Because the sheer pressure would be enough to make it a solid.
Yeah, it'd have to be mixed with rock, though. Anyways,
perhaps we'll know. Maybe eventually one day we'll know. Maybe we will actually do what things like Arthur C. Clarke and Isaac Asimov and Heinlein said we would, which would be going to these planets, sending robotic probes, which instead of having solid hulls, have porous hulls to allow the atmosphere to not crush them.
Actually, it would not be crushed by the gravity inside the core.
It's the pressure. It's the atmospheric pressure.
Yes, the gravity would be about 0.
But we know that the atmospheric pressures on these giant planets are such that if we try to go there ourselves, we would be compacted.
Yes, we would.
But if you have a spacecraft that equalizes, maybe that would survive long enough to get down and see something, and maybe hopefully report home what it's seen. But
I get a feeling if you could build a spacecraft that would actually make it to the core of Jupiter, then you probably would already know before that what the core of Jupiter is made out of.
Well, I think the current theory is it's metallic hydrogen. So it'd be nice to either prove or disprove.
Yep.
Right. It is 9:30 p.m. Eastern Daylight Time. So you are listening to the Event Horizon on Astronomy.FM. Sorry, Marty, I had to steal your line.
That's fine. I want to welcome Einstein's Ghost into our chat room. Yes, somebody actually made it here. That's cool. I posted something in chat, and it took about a minute to actually show up. So we're getting a little bit in there.
Now, tomorrow night.
Tomorrow
Tomorrow night is the 28th of October.
Yes,
And if you are a diehard astronomer, you know that it's International Observe the Moon Night. And we have a very nice first quarter moon for that. So let's get moonstruck on International Observe the Moon Night. Now, a lot of people all around the world gather together. They set up events coordinated by the internet. Let me get this right. By the LPI, which is the Lunar Planetary Team at NASA. I'm probably going to get shot by a certain couple of guys for getting that slightly mangled. But INOMN is sponsored by NASA's Lunar Reconnaissance Orbiter and with the Lunar and Planetary Institute in Arizona. That's an interesting segue. Who was I talking to last week on the Comet Watch? But 3 chaps from Lunar and Planetary Institute. So this is a chance to do some wicked good outreach, to get people looking through binoculars, through telescopes, and having a good look at the moon. The moon is not dead. We all think it's dead. Thank you. Starstorm, as you can gather, Starstorm is beside me and commenting when she chooses to. But the thing is, it is still very much an ongoing thing. We still see impacts on the moon, sometimes from space debris, sometimes from micrometeoroids, sometimes from fairly large chunks of rock. And the fun thing is, people can actually take part in the observations of the moon and see where these chunks of rock land. Why are we doing this, you're asking? Very simple. It's still very much on the books that there's going to be an international moon base, even if Elon Musk has to build Moonbase Alpha on his own first. But you know what? We need the moon because it is a perfect stepping stone to the outer planets. We can test their technology for Mars. We can test their technology to visit the asteroid belt and other places. This is the place you do it. You do it close to home because that way, if there's a problem, you can fix it. You can get support to the guys testing the kit, and you can, if necessary, save their lives. We first went to the moon in 1969. Why did we go? Well, it was the height of the Cold War.
Because it was there.
And because it was there, yeah. But you know what? Probably the best thing we ever did as a species, going to the moon. Everything else was put on hold because everybody around the world wanted to know what was going on. They wanted to catch up with NASA and see what was happening. They wanted to see mankind's first step onto another body. Even though it was our nearest neighbor in the solar system, it was still quite a step. Neil Armstrong did a really spectacular job of manually landing the orbiter. I believe it was supposed to have been done by the computer.
The lander?
But the lander kept the computer.
I hope he didn't land the orbiter. That would be a bad thing.
But the LEM computer kept crashing when it was coming into the landing phase. So Neil Armstrong made a command decision. He did a manual landing. Was he off target? Yeah, he missed the actual point they were supposed to have landed.
Were they trying to dodge some rocks too?
Yes, he was. That was the thing. He was trying to make sure that when he actually put the lunar module down, it was actually on a even keel and would be able to launch again. They really did not understand the lunar surface. There was people who believed that it was covered in dust and the LEM was going to sink into it to be lost.
Well, it was covered with dust, but they just didn't quite know how deep it was.
Well, yes. There'd been stories like I think it was Arthur C. Clarke's A Drop of Moon Dust, where a lunar exploration vehicle gets sucked under. We just didn't know. Our best estimates were it could either be very, very thin or it could be very, very deep. And they tried to pick a landing spot that was supposed to be solid ground. They picked a good spot. They were I think they were right on the lip of a crater, weren't they, in the end?
I don't remember.
but they were pretty close to the rock field, which would have been a bad thing, because if it had been at an angle, I don't think they'd have had a very good time at launch when they came to leave.
Mm-hmm.
But they did it. If anything, the fact that it was a manual landing showed us just how good our stuff was. It was good enough that a man could take over and do what was supposed to have been the impossible. We did it. We went back a few more times. The program got killed in favor of the space shuttle,
mm-hmm.
which was, it was okay. We were launching once a month. People getting complacent about space travel, and we had a couple of very nasty disasters. And it took the likes of theoretical physicist John Feidman. Can't remember his first name.
Richard Feynman.
Richard Feynman, thank you. To really blow a gasket on the inquiry, and because he was going to refuse to sign the inquiry report because they wouldn't let him. They kept trying to gag him, and he says, "If you don't let me speak, I won't sign it, and it won't be complete." So in the end, they let him do his simple little physics experiment with a rubber O-ring and some cryogenic material, dry ice, liquid nitrogen. And he showed them what happens when the O-rings on the SRBs are exposed to extreme cold. That's what caused the Challenger disaster. Mm-hmm. The rings failed, and it allowed hot gases to go where they really shouldn't be. So in the end, they undertook to fix the issue. They made it better, and we started flying again. We got complacent again. Then some debris from the fuel tank hit the wing of it wasn't Columbia.
Yep.
Columbia, thank you. And we had our second disaster because it tore off and opened a hole in the actual wing, which during re-entry allowed superheated gases in, and it destroyed the shuttle.
Mm-hmm.
In fact, there were so many people trying to second guess why it was happening. It took a while for it to come out what it was. So every time now, after that, the shuttle launched, when they got back, they had to remove 90% of the foam from the fuel tank.
Mm-hmm.
And then they had to fly upside down by the ISS for the ISS to take photographs of the heat shield, just to be 100% happy that there was no further damage. And they then started having to carry sufficient equipment to repair small breach so they could re-enter. Either that, or they'd have to leave that particular shuttle in orbit and then launch a second one to go fetch them home, do the rescue.
Mm-hmm.
Now, later on with Hubble, we really did stretch safety-wise things to the limit. Hubble is not really in a suitable orbit for repair missions, because it has to be in a certain place in the sky in order to A, be well away from the sun, and B, to observe better the objects it does. It is a long way out. It is way beyond low Earth orbit, which was taking the shuttle into a whole new place.
Well, I think isn't only about 350 miles out compared to 250 miles, something like that.
Yeah, but it was still pushing the safety factors on the whole thing.
The limit of the space shuttle.
Technically beyond the limit of the space shuttle,
mm-hmm.
technically. So what they did was they had throughout the whole mission, there was a second orbiter ready for immediate launch. So if, for instance, the engines on the orbiter doing the repair failed, they could send another one out to rescue the repair team and bring them home. Finally, to be honest, we were getting to the point where we realized space is still dangerous. The Russians still have accidents. They lose the odd cargo rocket still. Mm-hmm. We don't know how many disasters the Chinese have had. That's a state secret over there. So we may never know. And certainly Europe has had its issues with its launches and failures. It happens. I remember one of the early Ariane launches. We lost a pair of space probes called Stereo, the original Stereo, because they were 4 probes. They were put on an Ariane. I think it was 5's initial launch, and they put the wrong They loaded the computers with the wrong software. They didn't use Ariane 5 software. They used a previous generation of software for the motors. And there was the commands when given caused the rocket to malfunction, so that the space probes on board they had to abort the rocket and destroy it for safety. So we just lost 4 space probes. That's 1 space mission completely and utterly wiped out. Now, we've learned from that, obviously, but I think the thing is, one of the things we really, really have to do is we have to get used to the idea that yes, we can go to space, we can go to low Earth orbit, we can go to high Earth orbit, we can go beyond there, but there's always going to be a risk. And that means that the people building the equipment have to be more vigilant and not just get used to, oh, we're building the latest SLS, Super Falcon or whatever. So yeah, we've done this how many times before? Let's just keep doing what we do. You have to be vigilant. You have to keep your mind on the job. You have to keep your eye on the ball about what's going on.
That's right. Don't send a guy named Igor to go get the disc off the desk.
No.
You might grab the one that says Abby something.
Yeah. It might be the disc that says, this is Abby Shuto's.
Abby Normal.
Dear. But the thing is, we get complacent. And when we get complacent, we make mistakes. And the complacency needs to be something we keep aware of. Apollo 1 was caused by using oxygen, high pressure oxygen, basically at sea level, and having too much Velcro in the cockpit, basically. Velcro in a high pressure oxygen atmosphere ignites. And that was basically one of the basic reasons we had the fire. Having said that, what would have Gus, Roger, and I'm having a terrible night. I can't remember names. Derek.
Ed White.
Thank you. What would they have said if they'd survived? We want to continue. That's what Deke Slayton told the inquiry. We kept going. Deke got them to listen and to understand that, yeah, we lost 3 guys. We have to figure out and look at what went wrong. But just because we lost those guys, they are the very people that will want us to continue. They would want us to go and keep doing the mission, to go to the moon, to bring back information, to bring back samples so we can look at them, we can analyze them, and we can learn more about our neighbor. It happened. Thankfully, the commission listened to the voices of sanity, and Apollo continued, and we made it to the moon at the end, just right at the end of the decade, 1969. Would I wanted Apollo to continue? Too right. Because you know what? We had a great workhorse in the Saturn V. We had people being employed. They were paying taxes. That meant that the GDP, the gross product of this country was going up all the time. Mm-hmm. Yes, it's expensive to build Saturn V's. It's expensive to build SLS. Musk has made it clear that his super rocket for Mars is being financed by a big production run of Falcon 9, of Falcon X, of Super Falcon X, because he wants the money there. He wants to go to Mars. He wants to go out into the solar system. And that's how he's going to do it, because he says, yeah, I can build the super rocket to end all super rockets. But who's going to put their payloads on it when it's not proven? So what we do is we keep a big supply of the proven product to hand, and we sell space on those. That pays for the research. It pays for the R&D and the development. He's prepared to do this. He's put his own money on the line, and it took him 4 launches to get a successful rocket. but he did it. Steve Bezos is bringing back Apollo-style F1 engines for his Blue Yonder project. He believes in space just as well and as much as Musk does, because they believe that whether there is actually money in it for them, they must be making money or they wouldn't be doing it.
Mm-hmm.
Let's face it. If they ain't making money, we ain't going to let them do it. It's called economics.
Sometimes you just got to stand up and yell, let's get the Falcon back into space.
Yeah. And maybe one day we'll have the Millennium Falcon for space.
Mm-hmm.
Hang on, I'm being paged. Hang on a second.
All right.
Marty, take over for a moment.
All right, I will be taking over for a second. Well, we have the sun, by the way. Didn't talk about the sun. There is a couple of sunspots on the sun right now, so you can do a little bit of observing. They're pretty small. One of them's growing just a little bit. The southern one was a single spot. Now it's actually two spots, but they're pretty small Earth size, so not too much that way to see. But yeah, a couple of sunspots, a little bit of observing. Look at space weather. You'll see that somebody photographed some what looked like blue aurora, but it turns out it was just Russian rocket plume. But check out the pictures; they're actually pretty cool. Go to spaceweather.com for those. Let's see, what do we got going around in this? Launch is coming up on Saturday, November 11th. The launch of the we're talking about rocket launches. Orbital ATK cargo resupply mission to the International Space Station. That's coming up Saturday, November the 11th. You got a few more days so you can send your name to the planet Mars. So aboard the NASA's InSight lander. So I think that expires like November the 1st. So again, check out the NASA homepage for that if you want to get your name actually sent to the planet Mars. Go ahead, Nick. Still there?
Yeah, I'm still here.
All right.
I'm a season ticket holder. I started doing this when they first did this with Orion for first flight. So my name is going on the first flight of Orion. And every time they bring out a new thing, they ask you to log in with the details you've already given, and then you get space miles.
It's all free, right?
All free, yeah.
Of course. All right. Maybe if I remember to do that, I'll see if I can do that this weekend and send my name. And can you send multiple people's names?
They ask you really to do it individually.
Okay. Just one name?
Just one name at a time. It's like an airline ticket, Marty.
Well,
that's what you basically get. You get the facsimile of an airline ticket with a space. I guess it's either an Apollo or it's an ISS-style American spacesuit visor with your name underneath it and the number of space miles you've accumulated to date.
Well, it's kind of a virtual thing, though. You know, you're just sending your name electronically, so it's kind of, you get a couple of magnetic fluctuations and your name's on the planet Mars, sort of.
Yeah, I think they're putting them either onto a chip or onto a DVD or something.
Till the next solar flare wipes it out.
Well, if it's on a DVD, it ain't going to get wiped out that easy.
That's true.
Let's face it, they sent an LP into space with a needle on Voyager.
Mm-hmm.
There is an LP out there with all the sounds of Earth, people speaking the various languages, music, poetry, plus instructions on how to listen to it and recover it.
Mm-hmm.
So yeah, hey, that's good fun. Could you imagine if that offer had been around to have your name put on Voyager?
Mm-hmm. Now, if we could just get our radio show to go out into space, we could have our radio show, the entire show, go to Mars.
That's easy to do, Marty. It's very easy to do, actually.
See, there you go.
So you just need a, let me see, microwave transmitter. You get a dish, a transmitter, a microphone, or a pair of microphones in our cases, and you point it at the planet Mars, and then you hit a button, and then you send a message to Mars. Be something in the gigahertz range.
Mm-hmm.
Get there.
Speaking of radio stuff, we got a request last week. I think it was in our Space Pirate Facebook page. Somebody wanted information on building a small radio telescope. He's got a dish and some other stuff, but needs more information. Got an idea of where somebody can go look up to build their own radio telescope?
There is stuff out there. The British Astronomical Association has a radio telescope section.
Okay.
They have lists of available technology that's well within people's price ranges. There's a couple of companies out there that will sell you everything you need to build a radio telescope. Actually, if you go to NASA and type it to their search engine and type in the words Project JOV, they will show you how to build what is basically a radio telescope.
Okay.
Using long wire antennas, you can listen to the Sun, Sagittarius A, Jupiter, and some of the more active galactic objects. So it is very, very simple to do, but it's having the space for the antennas. Mm-hmm. That's why a lot of people use dishes, and they're using, in a lot of cases, C-band dishes from the old satellite TV days. You remember when you had a big dish in the garden and it took up the whole garden, the neighbors thought you were spying for the NSA or something, GCHQ. Mm-hmm. People still use that. Some people are using dishes from their old satellite TV network, or they've got rid of them. But hey, you know what? Let's have a bit of fun. Take the LMB to bits, fix it.
Now, would something the size of those like 2-foot dishes, would that actually work, or does it have to be like one of the 8-footers?
I would think better to be an 8-foot dish. Mm-hmm. And to get it specifically for the frequencies you want to observe. Like I say, go to the British Astronomical Association website, and there's a link on their page to the radio astronomy section, and there are a lot of stuff there. They even have links to people who will provide the equipment. You can connect it to your computers, you can get chart recorders, everything. It's unbelievable what you can actually get that would turn your garden into a mini Jodrell bank, literally.
Mm-hmm. Or you could just, pitch a tent right at Jodrell Bank.
No, you can't do that,
unfortunately. You won't be there very long, but you could do that.
No, they'll come along and arrest you.
Exactly.
But if you want to do it, you can do it. But I'm going to tell you something right now. The more remote area you're in, the better. So if you live on the Shetland Islands, great. If you live on, say, Fire Island off near the Chesapeake, that type of area, probably a good place. But you really need to be in an area that is not very well served by the mobile phone operators, because one of the biggest nuisances to radio telescopes, you got it, your smartphone, because it's forever being polled either by the network or it's trying to reach out to find a network, and some of those signals can interfere. When you're at a radio telescope facility, you are made very, very clear this is a radio blackout area. I can't even use my ham radio gear there because it will interfere with the radio telescopes. It will create false signals through harmonics. Now, I've actually been able to, using a receiver, find at least 5 harmonics. I was just using 28 megahertz, which is an amateur radio band for high frequency. One of the things that's part of your licensing exam in the UK is listening for the harmonic of a radio signal. So that's the type of thing that interferes with radio telescopes. So guess what? You're going to have to be in a very radio quiet area. You can't even have a microwave on. Microwaves are no-nos because they broadcast very broadly. Yes, I know that you don't get the effect of the microwave radiation outside the oven, but they still generate interference. And they can actually create interference down through the electrical cables. Don't forget, in the US, the mains electricity is a 60 hertz signal. In the UK, it's 50 hertz. But you can cause interference with a microwave oven. So, we've been given a link.
We have a link?
I have a link. Yeah.
What do you have a link to?
Mission. Dawn mission has Dawn discovers possible ancient ocean remnants on Ceres.
Yes. So it might have, Ceres might have actually had a global ocean in the past. And so, of course, you still wonder what happened to it, stuff like that. So, but let's see. The Dawn team found Ceres crust is a mixture of ice, salts, and hydrated materials that were subjected to past and possible recent geological activities. So, new information constantly coming out of the Dawn mission around Ceres. And by the way, Ceres, you can see it rises, I think, about 2 in the morning, something like that. It is about 3 degrees away from the Beehive cluster in Cancer, constellation Cancer. So it's coming back around again. So we'll start be able to actually observe the dwarf planet Ceres once again.
Now, Julie Callisto Rodriguez, who's one of the project scientists, thinks there may be still some underground water there as well.
Mm-hmm.
So that could be interesting. The crust has a mixture of ice, salts, and hydrated materials that were subjected to past and maybe recent geologic activity.
Yes.
And this crust represents most of the ancient ocean, now. Mm-hmm. So the second study builds off the first and suggests it's a softer, more easily deformable layer but beneath the rigid surface crust, and which could be the signature of residual liquid left over from the ocean too.
Yes, indeed.
So, yep.
And a little, let's see, kind of a new discovery using the Hubble Space Telescope. Within galaxy clusters, there are clusters of galaxies out there. There's usually one central galaxy, and then kind of everything is around it, and then all the clusters surrounded by some dark matter. What they've been finding recently is that central galaxy is not exactly centered.
That could be interesting.
Let me put the link there for you. It could be off by about 40,000 light years from actual center. So they're wondering, gee, what's going on in galaxy clusters that would offset the central, most massive galaxy in that cluster, known as the brightest cluster galaxy. So they might have to modify some cold dark matter models because of this recent discovery and observation.
Well, I think the whole dark matter, dark energy thing is going to be something that's going to be kept boiling for quite a few years. I don't think we're going to see the end of it just yet.
I think so too.
Things. And I think that's one of the greatest things about astronomy is that we keep revisiting old ideas, then we go away with newer ideas. We come back, maybe there's something there that could be right, but we'll put it into the new idea and see what happens.
Mm-hmm.
So that's the nice thing about science. It's not cut and dry. It's not very simple. It is often very complex. And sometimes when we chuck an idea out, we may have to go back to it and say, well, maybe this is partially right. Let's try this. Let's try that. And then we get an answer that maybe let's experiment. Let's see what happens in our simulations. And we're getting there.
Mm-hmm.
Anyway,
I think it's just about that time.
It is about that time. Captain Savick, USS Miranda, awaiting 3 to beam up.
Well, everybody, I want to thank you for all listening in tonight. Don't forget we've got more programming coming up after the event horizon, and we'll repeat those programs every 4 hours for the next 24 hours. All right, everybody, time for us to roll on out. Get some observing done this weekend. Observe the moon, show it to your friends. And hope you got some nice clear weather for it. Good night, all.
Good night, everyone. Look up.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM. There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.